All right, the last time I was talking about Galileo and the Inquisition, and the fact that he was put under house arrest for the last 10 years of his life. Um, actually, that's not the end of the story for Galileo uh, and the Roman Catholic Church. So it turns out that I think it was the 1990s. I don't remember exactly what year it was, but there was the Pope at the time, who was named John Paul the First. I'm sorry, John Paul the Second. John Paul the Second. So John Paul the Second, um, officially. So this, remember, this is in the 1990s. So this is like 400 years or so, almost 400 years after the death of Galileo. Um, John Paul the Second pardoned um, Galileo and said that he had done nothing wrong. That indeed, I mean, if you think of that indeed he was right, that the Earth goes around the sun. so and I actually, I have to give Pope John Paul II credit. I mean, he's since passed away, certainly, and there's been a couple of popes since him. But one of the things that Pope John Paul II did is he established a uh, they decided to put money towards a very modern telescope, which I think is in. I could be wrong about this. You can look it up on yourselves, but I think it's in. I think it's near Tucson, Arizona, and it's the Vatican's telescope. It's a modern telescope, and the idea was that the Roman Catholic Church would not make those kind of mistakes again. That it would embrace science, the discoveries of science, and yeah. All right. Anyhow, the kind of continuing story of Galileo. Um, Actually, there's a really famous um, one of the Apollo missions to the moon, where the astronauts, one of the astronauts in particular, you can, if you ever just you can just go on YouTube and just type in um, feather and hammer on the moon. Uh, and they actually perform an experiment that Galileo himself proposed. He said that, and he wasn't talking about the moon in particular because he had no idea whether the moon had an atmosphere or not. But remember, Galileo is the first one to think of the moon as another world unto itself, and not a perfect sphere. Um, but at any rate, this Apollo mission, I think it was Apollo 17. I can't remember which one it was, but for some reason in the back of my head I'm thinking Apollo 17. This one astronaut brought with him the a feather and a hammer, and so Galileo actually said this during his lifetime that in the absence of air resistance, and by the way, this goes completely against what Aristotle told everyone. In the absence of air resistance, a hammer and a feather would fall with the same rate. Um, and if you drop them from the same height, they would hit the ground at the same time. And indeed, that's exactly what happened. I'll try to look up the YouTube um, video on that, and I'll put a link. I'll try to put a link in Blackboard, or if I don't, just send me an email and remind me, and I'll put a link. Um, at any rate, let's move on. So when Galileo dies, it's the year 1642, and in that year, almost almost a cosmic coincidence, the, the the genius of Isaac Newton is born. Isaac Newton, born in 1642, he passes away in 1726. So that, people often make comments or um, interesting observations about this. Um, Anyhow, there's a famous picture of Isaac Newton doing his experiment with light. He did a lot of studies with light, proving that white light was made of all the colors of the rainbow. That's what this picture is depicting. He made huge advances in mathematics and in physics, and certainly in astronomy. All right. So, and in fact, he and Kepler, and Galileo, made pretty much the topic of astrophysics, that physics could be extended into the realm of astronomy. Um, all right. So he pioneered the modern study of motion. So his first law of motion is actually the same as Galileo's law of motion. In fact, he basically uses Galileo's law of motion. He also and he goes much further. By the way, he studied optics, which is of course the study of light. He just studies gravity and comes up with a mathematical formula that describes gravitation. He comes up with the mathematics of calculus, which, if you've never had calculus before, it's the mathematics of change. It was a huge step for humanity when calculus is invented, or discovered, really. And when it's discovered, certainly after it's discovered, there's all sorts of problems that humans can now solve that we couldn't solve before calculus comes along. And in fact, it's not until the 20th century, the early part of the 20th century, Newton's laws of motion and his law of gravity were they were seen as absolutely true, because every single time we performed experiments, Newton's laws of motion and his law of gravity seemed to be accurate. In fact, it's really only in extreme situations that they begin to depart from being able to predict reality, and those extreme situations are described in fact, Einstein's theory of relativity. When you start to get close to the speed of light, his laws of motion have to be modified basically, that's what the theory of relativity is all about. And then his law of gravitation has to be modified as well, and that's in fact what the theory of it's called general relativity. So Einstein came up with both of those: the theory of relativity, which has to do with approaching the speed of light, and then the theory of special relativity. Special relativity is moving close to the speed of light, and the theory of general relativity, which is that's the modern theory of gravity. The theory that describes black holes and so forth is the theory of general relativity. It's an extremely complicated area of mathematics, and it's not at all a simple thing. Like Newton's law of gravitation, you can write down and even if somebody had algebra in high school, they can understand it. It's not that complicated. In fact, we'll deal with that in chapter 3. All right. So that yeah. There's one really important. I don't know why they didn't include it in this PowerPoint presentation, but there's another really important contribution of Isaac Newton, and that contribution is, of course, the invention, and he did this of the reflective telescope. All right, so before Newton comes along, the telescopes. Remember Galileo's the first one to have a telescope that he uses to look at the night sky. But then many people follow him and do the same thing and start to observe the night sky and so forth. But what Newton realized is having like the two lenses, right? The objective lens, that's the big lens at the front, and then a smaller lens, the eyepiece in the back. That there were certain restrictions with having two lenses, and so Newton says, hey, well, wait a second. What if I used a mirror and I captured some of the light with the mirror, and then using using another mirror, I bend the light into an eyepiece, and that's the modern telescope that people use, right? It's rare to actually have two, like a Galileo's telescopes are called refracting telescopes, where the light is bent, and then there's reflecting telescopes where the light comes in to an opening, and then it's focused in with a parabolic mirror. The mirror is in a parabola shape, and it brings the light to a focus. So that's Isaac Newton. That's probably one of his great contributions, as well as the theory of gravity and combining the theory of gravity with Kepler's third law, coming up with what's called the modified version of Kepler's third law. He's the one that does the modification, and then it becomes universal. Kepler's third law is designed only to explain what goes on in the solar system. Newton's modified version of Kepler's third law is universal. It can be used anywhere in the universe. All right, so since the time, so we're going to get to more modern. This is towards the end of the chapter. All right, so Herschel was another English guy. He and his sister Carol just make numerous discoveries with a fairly large telescope. He's the first one in modern times to discover a planet. He discovers the planet Uranus, and it was in the year, so this is right when the United States is about to become a country. Well, I guess, it's after we declared our independence from England. So this is in 1781. Herschel discovers the planet Uranus. And very quickly, around the world, not very quickly, but the word gets out and people find Uranus. And it turns out that other people discovered Uranus, or discovered this planet, but then didn't go back and find it again. Herschel discovers it as a planet, and then forever it becomes a planet. Other people find irregularities in the orbit, and that leads to the discovery of Neptune. And then since that time, there have been, of course, lots of advances in larger and larger telescopes. I mean, heck, we even have space telescopes nowadays. The Hubble Space Telescope, and that's a very old telescope now. And now we have the modern James Webb Space Telescope. With photography, we're able to take pictures over longer time, so that you can build up a picture of very faint objects the discoveries just go on and on with these newer telescopes, newer technology.